So, hello guys, today we are going to solve problem based on queue. Okay, so the problem number 622. Okay, so I'm going to share my screen with you that everything visible with you. Okay, so here this is my screen. Okay, and here you can see I'm going to solve this problem. Design a circular queue. Okay, so here in this problem we are going to design circular queue. Okay, so here this is the statement design your implementation of the circular queue. The circular queue is a linear data structure data structure in which the operation are performed based on the first in first out principle. And last position is connected back to the first position to make a circle. It is called a ring buffer. Okay, so guys, we are going to solve circular linked list. Okay, so if I'm going to reset this, actually I already solved this code. Okay, so here we are going to write these functions, these given by the LeetCode. Okay, these function. So I'm going to create enqueue, dequeue, front, rear, and is empty. So I need to write these function. Okay, then we create our circular linked list. Sorry, not linked list, circular queue. Okay, so here you can see I have in input my circle in queue. Okay, so here these are the inputs 1 2 3 4. Okay, and here this is the output null true false 3 true 4. Okay, 3. So actually I'm going to tell you what is the NQDQ. Okay, so here I already explained everything in previous video. If you have doubt, then you can go and watch. Okay, NQ means add the item at the top. Okay, so like if you want to add the item inside the top, then it is called the NQ. DQ means remove the item from the front. Okay, NQ means add the item at the back of the queue. Okay, and DQ means remove the item from the front. Okay, peak means front item is located in the front. Just see who is at the front. Okay, and is empty means check if the queue has no element. Okay, is full only like check if queue is full. Okay, so we are going to perform these operations. Okay, so here this is the problem number 622. Okay, so inside this, where is my seat? This is my seat. Okay, so initially we have q equals to 0 0 0. Maximum size equals to 3. Front is equals to 0. Okay, front means top element, first element, or rear means last element. Okay, count equals to 0. So these are the variables. We need to take these variables in initial stage. Okay, so here I'm going to enqueue means add the element from the last. Okay, or you can say at the end of line queue. Okay, so we are going to add one by one 10, 20, and 30. Okay, so here I'm going to add in queue 10. So I'm going to add 10. Okay, so initially I have rear -1, front 0, count is 0, or in queue state is 0 0 0. Initially I took this. Okay, q equals to 0 comma 0 comma 0 in list. Okay, but here I'm going to use this front. I'm going to use this formula. Okay, for calculating real. So real, I took rear means last element. Okay, so -1 is our rear. Okay, plus 1. Okay, and I'm going to divide it with the maximum size. So what I have in maximum size 3. Okay, so -1 is the value of rear. Okay, so how can we calculate rear last element like this? Okay, -1 plus 1. -1 means rear. Okay, plus 1 and divided by the maximum size is 3 because we have 3 elements 0 comma 0 comma 0 in queue. Okay, so I got reminder 0. Okay, so now our rear will become 0 after calculating here. it will become 0. Now font is 0. Okay, after before I have count is 0, but after adding this 10, so it will become 1 here, count will be 1. So in place 0, I replace this 0 with 10. Okay, so I got 10, 0 and 0. Okay, and it will return true. I added 10 here. After this I'm going to add 20. Okay, so after 10 I'm going to add 20 in the last. Okay, I'm not going to add in beginning before the 10. Okay, I'm going to add element after the 10. Okay, so here rear, what is the value of rear now? Now rear is 0, so 0 plus 1 is divided by maximum size, that is 3. So I get remainder equals to 1. Okay, so now rear will be 1, so I'm going to reset our rear is equals to 1. Okay, now front is 0 and count after 1 I increase it by 1, so it will become 2. And here I added 20 after 10. Okay, and return true. And here after 20 I am going to add 30 after the 20. Okay, so rear, now our rear is 1, so 1 plus 1 is divided by 3, that is maximum size. Okay, so I got 2, reminder I got 2. So rear is 2, front was also 0, and count after 2 it increased by 1, so that it will become 3. Okay, so now q state is 10, 20 and 30. Okay, and it will return true. So first of all guys, I need to create one class. Okay. Mm-hmm. Mm-hmm. Here I can create here. Okay, so class equals to, you can see here I have one class my I need to copy these things from here. Okay, so here this is my class my queue, and this is our function. Okay, so self and k and integer. Okay, so initialize queue with the size k. Okay, so here I'm going to initialize queue with size k. Okay, so here initially I have queue self dot queue. So what I have in my queue, queue is equals to 0. Okay, so in list I have q equals to 0 into k. So k is the maximum size. Okay, or this is like fixed size array. So after multiplying like this, so what is the value of k? That is 3. Okay, because maximum size I have 3. Okay, so it will become like this. In list I got 0 comma 0 comma 0. Now our q is 0 comma 0 comma 0. After this I am going to define another variable, that is max size. Okay guys, I already took max size equals to 3. So here I need to change s into a capital S. Okay, so this is maximum size, that is k. Okay, and after this front, so here I'm going to define another variable, that is self dot front. It is also 0. And here self dot rear is equals to -1. And here self dot count is equals to 0. Okay, so here I'm going to define what is it is doing in comments. Okay, so here self dot front means front element, index of front element. So I'm going to write index of front element. Okay, and minus means -1 means it is the index of last element. index of last element. Self dot count means current number of element. Current number of element. Okay, so this is our class of my circular queue. Okay, here this is the constructor. I'm going to define variable. These are queue. Okay, maximum size. What is the maximum size of the your queue? Okay, front means it will give you element. Sorry, front elements index. Okay, and rear means it will give you last index of the element, index of the last element. Okay, and count means initially we have zero, count means current number of element. Okay, so this is our class. I already defined everything. Q equals to 0 comma 0, and maximum size equals to 3, front equals to 0, and rear minus 1, and count equals to 0. Okay, so now I am going to create Q. I already explained how can we create Q. Okay, so I'm going to add 10. Okay, and this is the formula for calculating rear. Okay, and now these are the values for rear, font, and front, and count. Okay, these things. Okay, add 10 here and it will return true. After this I'm going to take 20 in q20. Okay, so this is the formula for calculate the real and sorry, rear, not real. Now rear it will become 1, font 0, and count 2. Okay, after 20 I'm going to add 30. Okay, so 1 plus 1 divided by 3. Okay, so this is the calculation of rear. Now rear will become 2, font is 0, count is 3, and here this is our final q 10, 20, and 30, and return true. Okay, so here I'm going to create one function, that is enQueue. enQueue, QU EUE. Okay, here I'm going to pass self comma value. Our value should be in integer, so int. So this is the bool. Check. Now we are going to check if queue is full. Okay, so here I'm going to check if queue is full. Okay, then I'm going to define one condition. If self dot, if solve dot is full, then it will return false. Return what? False. Now we are going to move rear to the next position circularly. Okay, so here I'm going to write move rear to next position. Circularly. Okay, so I'm going to define rear. Rear means last element. Okay, so we are going to move rear to the next position circularly. Okay, so here I'm going to define variable self dot rear. Okay, so now we have rear equals to -1. Okay, so here I'm going to calculate next now we are going to move rear to the next position circularly. Okay, so here rear equals to self dot rear plus 1. Okay guys, this is the formula for calculating rear, and it is divided by self dot maximum size. Okay, so here we can calculate our rear. So self dot rear equals to self dot rear. So now we have minus 1 rear. Okay, so here minus 1 plus 1. Okay, this is plus 1. Okay, and divided by with the maximum size, that is 3. So I got 0. So now new rear will become 1 here. Sorry, now new rear will become 0. Okay, previously I have minus 1, and now it will become 0. Okay, so here I got 0. And here self dot q u e. So here self dot rear. So self dot q equals to self dot rear equals to value. Okay, so q state, this is for q state. Now q will become 10 like this. Okay, so q equals to self dot rear. Okay, so at 0 I have 10. Now count self dot count increase by 1. Okay, then it will return true. Okay guys, so this function for enqueue. Okay, so here you need to calculate rear. Okay, rear to the like move rear to the next position circularly. With the help of this formula we can move rear to the next position circularly. Okay, here you need to insert qlu inside the queue state. Sorry, nql, sorry, 10 inside the queue. Okay, and increase the count by 1. Okay, so this is our code for enqueue. I already explained. Okay, and this is the class. I already explained this class also. Now we on to dequeue. Dequeue means remove the element. Okay, so we already did this nq10, nq20, nq30. Now q, our q is 10, 20, and 30. Font is 0. So here you can see our front is 0, and it is front, not font. Okay, so font equals to 0, rear equals to 2, and count equals to 3 in enqueue. So I'm going to take this same. Rear equals to 2, front equals to 0, and count equals to 3, and maximum size equals to 3. Okay, so here I'm going to write code. So before dequeue, okay, I have this list 10, 20, and 30. Dequeue means you need to remove first element. Okay, I mean element from the mm, in the starting of queue. Okay, so I got 20 and 30 in output. Okay, after removing 10. Okay, so after dequeue, front will become 20 and 30. So we have two element after dequeue, 20 and 30. Okay guys, and this is the, I mean before initial, if we are going to initialize element, so font equals to 0, rear equals to 2, and count equals to 3. Okay, so same thing, font equals to 0, rear equals to 2, and count equals to 3. Okay, so q is 10, 20 is 30, 10, 20, and 30. Okay, now we are going to calculate. Okay, we are going to calculate font. So here I'm going to write function name, that is dequeue. So here small de, capital Q U E U E. I'm going to pass self. Here I'm going to pass bool. Okay, so I'm going to check if Q is empty. So here I'm going to write in heading, check if Q is empty. Okay, so with the help of this condition, I'm going to check if self dot is full. Okay, then return false. Okay, like if you already have any queue that is empty, then you need to return false, because we can't remove any element, because it doesn't have any element there. So here now I am going to move front point circularly. Okay, because we are going to remove from front, so that's why I am going to move front point circularly. Okay, so here I'm going to write comment in comment. Okay, so move front pointer circularly, and here I'm going to pass self dot front is equals to self dot front self dot front plus 1. So this is the formula for move the front circularly. Okay, so here I'm going to divide this with self dot maximum size. Okay guys, so here self dot front equals to self dot front plus 1. Okay, and it divided with the maximum size, that is 3. Okay, so here I'm going to decrease it with 1. Okay, so here self dot count, so count now decrease by 1 because I remove one element. Okay, and remove true, sorry, return true. It's mean we are going to move our front. Before I have front at 10, but after adding 1 in the front, now front plus 1 means before I have front at 20. Here I'm going to explain here. Before I have front at 10. Okay, so if you are going to add 1, okay, so it will move here in 20. Okay, so with the help of this formula, okay, so front equals to 0, I mean 0, at 0 index I have front. Okay, now I am going to add 1 index here. Okay, and divided with the size of, like, how many element present there. Okay, so we have 3 element. Okay, so I'm going to divide it with the size, maximum size. So I got 1 here, so front is 1. Okay, rear is 2 and count is 2. Okay, so here that's that is like, that's why our front move here. Okay, at index 2. These are the index, guys. Okay, and rear is 2 and count is to 2. Okay, return true with the help of this, and count decrease by 1. Here similarly I add one element in rear. Okay, so here uh, I add one element, sorry, I add one in rear. Okay, every time, so it will become 0 1 2, these are the index, and here I in queue, I mean I'm going to, I added one values. Okay, that 10 20 and 30. Okay, and queue will become like any number, 20 30 40 50, like this. Now we are going to calculate front. I'm going to write function for front. Okay, so now after some operation, q look like this: 10 20 and 30. Okay, 10 20 and 30. Front is 1, rear is 2, count is 2. Front is 1, rear is 2, count is 2. So logical sequence 2 and 30. Okay, so here I'm going to start. I'm going to define function front, FORANT, front. Here I'm going to pass self. I'm going to write int. Okay, if self dot is empty, is empty colon, then it will return -1. Okay, like if you have empty queue, then it will return -1. Okay, and otherwise it will return self.queue, self.queue, and here self.front. Okay guys, so here this is for calculating front. Okay, so in starting we have front equals to 1. Okay, this one. Okay, q is this. Okay, and return nothing. So first of all I need to check that is it is empty or not. Okay, and we can also check count is not equals to 0. If it count is equals to 0, then it will empty. Okay, but we don't have empty queue because we have element that is 20 and 30 whatever. Okay, so here this is our original queue. Okay, so here I'm going to return self.queue self.front, so it will give you front element that is queue at index 1. What we have, that is 2. Front 1, what we have, 20. So I get 20 here. Self.queue self.front, so what is the value of front, 1. So I got 20. Okay guys, I hope you got it. Now 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 what, we are going to calculate rears. Okay, so here I'm going to define one function, def rear. Here I'm going to pass self. In output I want integer, so this is integer, and here I'm going to check if it is empty or not. Okay, so self dot is full, then it will return -1. If it is full, then it will return -1. Otherwise it will return what, it will return self dot queue and self dot rear. So I got my rear value. So here we have size equals to 3 because we have 3 element, 10, 20 and 30. Front is 1, rear is 2 and count is 2. Okay, so we can check here, is this empty? No, because we have element. Okay, like if it is empty then your count is 0, so this is false. Okay, then we move here. Okay, so here in this condition, self dot queue self dot rear. So what is the index of rear? So I have rear equals to 2. Okay, so this is our rear. Now we can check at index 2 what we have. At index 0 I have 10, at index 1 I have 20, at index 2 I have 30. Okay, so it will return 30. So 30 is our output and rear is 30 is the our rear. Okay, now we are going to define one function for empty. So I am going to write is empty, that is function empty. Here I am going to pass self and bool, and return I'm going to return self dot count is equals to 0. Okay, if it is your count is 0, then it is empty queue. Okay, so here, okay, now we can write the code for full. If your queue is full, then it will execute this function is full. Okay, I'm going to define function name that is full. Okay, here I'm going to pass self and output should be in bold, that is it will give you true and false. Okay, so here I'm going to return self dot count is equals to self dot max size. Okay, so here you can see if your count, Okay, is equals to maximum size. So we have three element, or you can see here we have three element, 20 and 30. Okay, so these three element, okay, is equals to with the maximum size, that is also 3. Okay, so self dot count means you have three element. Okay, count equals to 3, and that is equals to maximum size. So maximum size also 3, so this condition will true. So it return that queue is full. Okay, I hope guys you got it. So this is our circular link list, sorry, circular queue. Okay, every time I said that linked list, but it is not linked list, guys, sorry. It is like circular queue. We design circular queue, and this is the problem lead code 622. Okay, so we are going to solve upcoming problem. These are the upcoming problem: 933 225 346 and 3239. Okay, so bye bye, take care, see you in next video. Yes guys, tell me what happening. Daily facts, yes, tell me. मैम आई हैव जनरल क्वेश्चन, हैव माई असेंचर इंटरव्यू। असेंचर में डीएसए नहीं पूछता ब्रो, ऐसे ही जाओ और दे दो। असेंचर डीएसए नहीं पूछती है। नॉर्मल क्वेश्चन पूछेगी, लाइक व्हाट इज, अगर पाइथन में दे रहे हो तो व्हाट इज स्ट्रिंग, व्हाट इज डिफरेंस बिटवीन लिस्ट टपल, व्हाट इज मल्टी प्रोसेसिंग थ्रेडिंग, like this, what is lambda function, what is generator. So they ask these kind of question they will ask you, और प्रोजेक्ट के बारे में पढ़ लो। असेंचर डीएसए नहीं पूछती है। सो बेफिक्र रहो।